of the subject design patterns, and the topic we're doing is the bridge design pattern. Myself, Saurav Anand, Daniel Abhishekam, and Nagar Choudhury have done this assignment. So, what is a bridge design pattern? The bridge design pattern is a design pattern used in software engineering which is meant to decouple an abstraction from its implementation so that two can vary independently. The bridge uses encapsulation, aggregation, and can use inheritance to separate responsibility into different classes. So this is the basic introduction what is the bridge design pattern is all about. Now we come the motivation of it. Sometimes an abstraction should have different implementation. Suppose consider an object that handles persistence of objects over different platforms using either relational database or file subsystem structure like files and folders. A simple implementation might choose to extend the object itself to implement the functionality for both the file system and RDBMS. However, this implementation would create a problem. Inheritance binds implementation to abstraction and thus it would be difficult to modify, extend and reuse abstraction and implementation independently. So, and the intent of the bridge design pattern is to decouple abstraction from implementation so that two can vary independently.
Hello, here I am Daniel, and I'll be explaining the structure, the participants in collaboration, and an example for bridge pattern. Yes, so let me start with the structure of bridge pattern. So there's a client object, an abstraction class, and an implementer class. So we can see how the abstraction and implementer are decoupled or separated, as in contrast with the inheritance wherein the abstraction and implementer are permanently bound together. So we can see that the abstraction can be refined uh, without any changes made to the implementer. So abstraction is more or less independent in when in relation to the implementer, and implementer is an abstract class for the extending classes which can also be called concrete implementation classes. So that is about the structure. So the participants, as we have already seen, there's an abstraction class, and refined abstraction can be done on that abstraction class, and then an implementer and concrete implementers which extend from the implementer class. And now let's look into an example, a very basic example. um, there is this here we see a basic inheritance of rectangle class. So there's v1 rectangle, v2 rectangle. What we see here is basic inheritance example. So what if I have another shape, say circle, which also inherits from parent class shape? Now we have 1, 2, 3, 4 concrete implementer classes. And so there is we can say extra inheritance being done here. And what if I have another shape, say square, extending from the same parent class again shape? There will be 6 concrete implementer classes. So what we see here is overuse um, or yeah, it's an overburden on the inheritance. So it's called the combinational problem, overuse of inheritance. Now, what is bridge pattern? As we have already seen, it is useful when you have an abstraction that has different implementations. Now it allows the abstraction and the implementation to vary independently of each other. So as opposed to the previous example, to solve the two problems that we had seen, uh, we can use something like this, and this is called the abstraction uh, and implementation being separated using bridge pattern. So we have shape, rectangle, circle. These are refined abstractions. This is the abstraction class. This is the this is the implementer class, also called it is called here drawing. And then it has concrete implementers like v1 drawing, v2 drawing. So this is a class diagram which depicts how implementation and the abstraction is decoupled in a bridge pattern. So yeah, that's it from the examples. So that's a very basic example we are.
Consequences and as well as implementation issues in the bridge design pattern. So starting off with the applicability, needs to avoid a permanent binding between an abstraction and implementation. An abstraction and implementation should be extensively through subclasses. When implementation changes should not impact clients, and when the implementation should be completely hidden from the client. When unknown to the client, implementations are shared among objects. So that is the applicability and the consequences of bridge design pattern is extended to keep the interface to your client program constant while allowing you to change the actual kind of the class you display or use. This can prevent you from recompiling a complication set or user interface module, and also requires that you recompile the bridge itself and the actual and display classes, which means when the code is changed, when the client makes some changes in the code, then he doesn't need to recompile it again and again. When he changes the code, it automatically reflects in the uh, pattern. And implementation issues, how, where and when to decide which implementation to initiate. It depends. When if abstraction knows about all concrete implementers, then it can instantiate it in the constructor. Implementers can be shared and used, and the usage can be tracked. In this, we can track which changes have been made and where we can use the implementers. A class can inherit publicly from an abstract and privately from an implementation, but since it is static inheritance, it binds an implementation permanently to its interface.